Hello, welcome back to Code Station 33. Today we are going to look at some of the problems that come up when you're dealing with numbers inside of programming. So the computer has the ability to store numbers, but that storage is limited. There is a certain point at which a computer cannot store a number. And in order to maximize the storage the computer has, the designers of many programming languages agree to create different kinds of numbers. In mathematics, you typically would have integers, real numbers, whole numbers, counting numbers, in no particular order they're stated, and all of those different groups of numbers would be infinite. There is no limit to the size of an integer that you can list. You can list as big of a number as you want. In computer science, though, when I go and talk about an integer, it turns out there is a limit. There is a biggest size integer I can have. There was a story about a video, which you may have heard of before, Gangnam Style, when it was on YouTube, got so many likes that it actually ended up crashing YouTube. And the reason why it crashed YouTube is because the designers of that interface decided that the likes, the variable that holds the likes, should be of an integer type, which means that they could only have 2 to the 31st number of likes on that video. And as soon as that video went one more like than 2 to the 31st, it shut down. It shut down all of YouTube. It actually just crashed the whole thing. So what's the remedy for that? Well, it turns out there are other types of numbers that we can use inside of coding that let us know we want a bigger number. So instead of using an int or an integer, we could use a long, which is a much bigger space to store a bigger number. In decimals, we have also different size categories, and those are limited by size. The smaller one that we're going to look at today is called a float, as in floating point. You might recognize some of these words if you look at your calculator. You'll see that your calculator does have a float mode, which is a decimal mode on your calculator. That's what that means, floating point. You could also switch it to an integer mode where it only calculates in integers. So that integer mode, which is what most of the numbers that we're used to seeing in mathematics look like, no decimals, behaves a little differently in programming than it does in math class. So let's take a look at that and see kind of what exactly is going on. So I've started a Tinkercad just to kind of take a look at some of the math in here. It's still in block mode. I'm going to switch this to text mode. And I'm going to make this a little bigger for us all to see. There we go. So right now, just turning a pin on and off. We don't want to actually do any of that. What we're really interested in is just doing some math. So I'm going to get rid of all of this code here. There we go. And I'm going to start by defining a variable as an integer, int, and I'm going to call it my value. Notice I'm still using my good structure and camel case here. And the equal sign we talked about before means assign. It does not mean a comparison. So we're assigning it a value. And I'm going to assign it a value of 10 divided by 3. Now, in math class, if I was to ask you this question, you would give me an answer of 10 divided by 3 is a decimal, 3.333. But when I go ahead and print this out, let me start up my serial monitor. Actually, let me put this down here in the void loop, so it just prints the answer over and over again, and begin serial. That, and then we're going to go to serial print. And we're going to print the value of my value onto the screen, just so we can see what's going on. So hopefully I coded all this right. Let's see, check. Oh, what did I do? Oh, I forgot the period. There we go. Let me check what I did there. Whoops, my dyslexia kicked in. And I wrote that backwards. And that should be a capital S, I believe. There we go. Much better. Sorry about that. So now when I look at my serial monitor, I see I'm not getting the right answer. I'm getting the number 3, which for us doesn't work in math class. If you said to your teacher, if I take 10 divided by 3, I get 3, your teacher would just tell you incorrect. That's not the correct answer. What the computer's doing here is something called integer division. And the way integer division works is to keep the answer as an integer. If you start with integers, because both 10 and 3 are integers, when you divide those two answers, the result needs to be an integer, according to the language here. In order to make that happen, what the computer does, essentially, is throws away the decimal part and only keeps the integer part. So the integer part of that answer is 3. The decimal part would be the 0.3333. So the computer will just throw away the 0.3333. If I wanted to get it to actually do my value 2, the decimal part, I have to be careful here, because if I do this, 10 divided by 3, and try this, I'm going to do my value 2, I'm still going to get the 3. Watch what happens. There's my value 2. But this time it's 3.00. So the computer is saying, take my answer of 10 divided by 3 and store it as a decimal, which would be 3.00. It's still not giving me the 3 that I want it to do. So I have to go a little bit further. I have to tell the computer that I want these to be decimal division, not integer division. And there's a couple different ways of doing it. The first way is a little messy. You could do 10.0 and 3.0. And now for sure the number is written as a float, and we'll do decimal division. So I'm going to start that. And you can see we're going to get our 3.33 over and over and over again. That's what we wanted. But that's not as clean. There is a cleaner way of doing it. Instead of having to type in 10.0 and 3.0, what we could do is this really neat thing is we can add in an operation here. And we can tell the computer that we want it to treat the 10 as a decimal by putting the word float in parentheses in front of the 10. Now, if the 10 is treated as a decimal, then it doesn't matter that the 3 is still treated as an integer. 3 into the decimal 10 will produce a decimal answer for the computer's logic. So when I run this now, I can see I get my 3.33333 as my answer. So this method of telling the computer that I want it to be a decimal and not be an integer is called casting. That's C-A-S-T-I-N-G, casting. And when we cast, we tell the computer that instead of using the type that you default to, which in this case would be an integer because there's no decimal point, we would like you to treat it as a decimal. So that's what works here. But it also works the other direction. If over here at the top I do 10.0, I can do the same thing and cast this as an int I'm just going to comment this out because we don't want to be distracted by that, and change this to 2. So let's think about what's going to happen here. The computer is definitely going to look at this 10 as a decimal, but then we're going to tell it, no, 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 don't look at it as a decimal, look at it as an integer. So anything that is a decimal part will be thrown away. So when the first time I run this and print my value, it's going to give me the 3. So let's give that a try. And you see now we get the 3 again, which is what we expected, even though the 10 is a decimal. And in fact, if I change this 10 to 10.7, it's still going to give me the 3. See? Still gives me my 3. Because the computer is telling us we're going to take this 10.7, we're going to treat it as an integer, which means we're going to throw away any of the decimal part. So the other thing that I wanted to cover in here, and I know we've talked about it a little bit before. Let me do this. So I'm just going to define my value and just set it equal to a value of 0. And I'm going to have the computer print it out, but before I print it out, I'm going to assign my value, the value that's already stored in my value, plus 1. And the reason why I have this example here is it's another case where real life math that we do in math class does not match with computer math. If I was to do this in my math class with my teacher would tell me that is not correct. You cannot say my value is equal to my value plus 1 because they're not equal. But in the computer, the equal sign does not mean comparison equals. It means something different. The equal sign means assign the value. So the way we read this properly in computer science is my value, the variable my value, which starts as 0, is assigned. That's what the equal sign is saying. Assign my value plus 1. So when I run this, each time it goes through the loop, let me clear out my serial monitor. Each time it goes through the loop, it's going to increase my value by 1. So I'm going to hit the Start Simulator. And you see how it's not increasing each time because I restarted at 0. So let me move this line and just put this in the setup. Actually, outside the setup, we want to have the scope so it exists in the whole thing. I don't know why I did that twice, but that's okay. Here we go. Let's start simulation. And you can see now it's counting up because my value is declared outside of the loop and starts at 0. So once the loop starts, it's just going to keep adding values and values. And we could just let this run to see, what does it do when it gets to that maximum value, which could be a fun experiment for you to do to find out what actually is happening when it does get to that total maximum value of 2 to the 31st. So that is all for today. I will see you next time.